This is my door alarm system built with the Grow Beginner kit. To make this project happen, I had to use different sensors and different cables from the beginner kit. Had to use button using the D6 port, as well as buzzer with the D5, LED in D4, and also the main part of the sound sensor connected to A2. All of them directly connected to the main part of the board, which is the center. So now I would like to show a quick demonstration. So when I press the button, the system alarms and the LED lights up. So watch the MATLAB graph that is tracking the sound. And then a door slam creates a loud sound spike that triggers the buzzer and a flashing LED. The graph clearly shows this voltage peak. So the system differentiates normal openings from violent slams, preventing false alarms. As you can see, this is the environmental noise that is being detected without making any sound. But now I'm going to show like a real demonstration in MATLAB. As you can see, the environmental sound keeps moving, but when a door is detected, you can see the spikes going up. In that case, it detected and gave me a sign that the door was open. But when the door gets slammed or gets closed, the voltage increases violently. So that means there's a specific amount of huge sound that is being processed by the sensor. So this code uses a state machine with 3 modes: disarm, armed, and alarm. The trigger alarm function activates alert for 3 seconds when thresholds are exceeded. So the key features that I used were the analog sound input on sound pin, the close threshold to be 3.5 volts to detect the slams, and also the real-time graph updates. That was the most interesting part of doing this project, to detect huge noise by using the sensor. This project demonstrates key concepts from EECS 101 because it implements a functional alarm system using MATLAB and Arduino. The system successfully detects door activity using sound analysis, triggering alerts, and thresholds that are exceeded. So I use different programming skills because I developed state machine to manage arm and disarm states. Also had to work with sensors and outputs with the Grow Beginner kit, plot and visualize real-time sensor data to distinguish various events, for example, the door being opened and closed violently. I had to optimize performance using a little bit of delay and threshold calibration to distinguish the magnitude of the sounds, as well as had to combine different computational thinking with mechatronics that result in a really good prototype for me that could be expanded for smart home applications. In conclusion, it showcases how basic programming and electronics can solve real-world security challenges. Thank you.